Hi everyone, my name's Sarah Bachmann. As you've just been told, I run National Precast Concrete Association. I've been doing that for about 14 years. So I'm going to put a bit of a different spin on building smart for you, and it's coming at it from an angle of talking about using more off-site manufactured products in construction. Organisations like the CFC for Construction Innovation, ACIF, have all recognised that using more off-site manufactured product in construction presents Australia in particular with one of the biggest opportunities for productivity improvement that we have seen in a long time. So today I'll talk a bit about precast concrete. I'll also address why precast is actually sustainable, even though it's often tarred with the brush that it's got a high embodied energy because of the cement in it. So I'm going to start off by, this is what we'll run through today in the presentation. So I'm going to show you a brief video in a minute. We're going to talk a little bit about sustainability and what that actually means. We're going to run through why precast is actually sustainable. I'll give you a couple of examples of sustainable precast projects, and then I'll update you on some of the innovations that the industry is offering. So we're now going to watch this video.
If we can prefabricate concrete wall panels and floor panels, it saves a lot of on-site labour.
It's going to save you money by having less waste on site, less manpower on site.
So we've got less crew, so there's increased speed to get the job done.
It's the savings that come from finishing the job sooner, which is often underrated.
You know, obviously speed of construction is what we're after, and we get a great benefit with precast.
So it's not unusual for us to offer time savings in the order of say 6 to 8 weeks on a mid-rise multi-residential project.
On this particular job, for instance, we received the drawings issued for construction last Monday, and they're being delivered 1 week later, 7 days later.
It's just a lot faster than obviously doing formwork and doing an in-situ deck. Yeah, pretty much a drop of flooring in a day on top of your formwork. Spark these plumbers up there next day, and then you start your seals. So you can pretty much turn a floor around in a week from landing your panels to pouring and landing walls on top of it.
And if there's an opportunity to reduce the amount of concrete and also reduce the amount of reinforcement, that delivers huge sustainability advantages.
Any sort of building system that minimises handling on site, so taking it in or taking it out, or just moving it around on the deck, has to be an advantage on site. It just frees up space for the contractor to put his work together and to come through these following trades. All those jobs had a very tight turnaround between the construction phase and the fitting out trades, literally one floor below. So it really speeded up construction.
Easy and quick options, just a big jigsaw puzzle really.
Safety is I guess, increased, or potential for hazards are reduced because there's less labour on site.
Safety side, it's a lot cleaner on site. No formwork there, so I've had a lot of visitors here on site. They're real surprised with how tidy the site is. Not really cluttered. There's a lot more space to store materials and stuff. Our trades are getting in there straight away.
So in terms of safety, we've got less site numbers on the project.
A lot of this is organised well and truly beforehand and before it's needed, because obviously, you know, it's not like you're going into Kmart and pulling off a couple of things off the shelves. These are all bespoke elements. They're all individually numbered, they're all individually manufactured, all individually checked, and so it's got to be done properly. So there is a lot of coordination that goes on in the background to ensure that the product comes to site in the sequence that it's going to go in, so that it can be installed. So we work very closely with both the builder and the installer.
We find that when we've already won a customer over to a precast solution, that from then on that they engage us very early in their tender and look at the precast solution. But then there's other jobs that come out to tender in traditional formwork, and then we have a job to do to convert that as quickly as we can to a precast solution.
Once you've got that process going, they'll design the formwork system, and the reinforcement basically takes that off our consultant's plate. So that's a good benefit in itself.
Because we had one package and one company looking after the full project from a precast point of view, it meant that there was one point of contact, very, very easy to deal with detailing.
Also at the same time we worked with the architect to look at certain elements which were very, very difficult to manufacture as they were designed. Because of our initial involvement, we were asked to develop the precast further.
I love the sort of the monolithic feel of precast, that it has that I guess the smoothness and the solidity of it just gives it a lot more presence.
And the base of the building was that it was a lotus seed, which has 4 pods, and hence that was replicated basically in the pods, the shape of the precast. And then once again, it was on the external, the facade, you had to turn the baguettes to obviously make that same pattern which followed the building.
We've got some very big transfers, we've got some big cantilevers, we've got a really dynamic structure, and it's all been put together like a kit of parts, so it's going to look like a beautiful finished. I think in the end result's going to be sort of like an absolute jewel, sort of like a beautiful building that's just immaculately put together, and I think that's the quality that you can get through precasting.
Columns typically are very small panels, which mean they're relatively expensive to fabricate and they're relatively expensive to install. So what we were able to do on this project was to increase the columns to double height columns, so there are only half the number of panels to make and only half the number of panels to install, and that really helped us with efficiency and it helped the overall price.
And the double height precast columns is something new in the industry, and it's definitely worked here for Grocon at Parklands. And the stairs, not something we've done on past projects, but the precast stairs have adopted, meant that we can get access to the working deck at all times. So the precast stairs come in directly and installed behind the precast stair cores.
A lot of structural elements that you find on building sites when you're done in situ, they don't look too pretty because they can't get the finishes that they need. With the precast that we've got here, it's both a structural element and an architectural element all in one. And so there are significant cost savings in terms of dematerialisation by using high quality precast structural / architectural elements.
So, as you can see, there are a lot of benefits to using precast, which I'll go over just very briefly in subsequent slides. we can see from this slide the changing definition of sustainability, and we can see that it was a fairly broad general definition back in 1987 by the United Nations, and it's changed to actually accept that sustainability isn't just about environment, but sustainability is actually about society, economy and the environment. And it's from that perspective that I'm going to talk about precast and the benefits. So from an environmental perspective, precast can use up to 30% less concrete. So flooring systems in particular, some of the flooring designs like ultrafloor and hollow core, because of the voids in the concrete or bubble deck, mean that 30% less concrete can be used, and that has to obviously offer sustainability. It's the sort of thing that can only be achieved in a factory. So I'll just take the opportunity now to differentiate between tilt-up and precast. And a lot of people use the two terms interchangeably, but they're actually not. So tilt-up is actually site poured, and tilt-up has been defined as a lifting method rather than a product. So tilt-up is where panels in particular are site cast. They're often stack cast, and then they're tilted and lifted and placed into position. Precast concrete is made in purpose-built factories. It's then trucked to site and craned into position. So because we're in a factory environment, that offers a whole raft of benefits, and it goes back to that comment that I made about using more off-site manufactured product. And this relates to anything that's made off-site in a factory. It takes it away from the building site. You have the ability to do things like use industry waste, so supplementary cementitious materials like fly ash and slag, that would otherwise be waste. You're minimising your waste on site because any materials that go into using the concrete can be reused and recycled very often. Usually precast is locally supplied, but that will depend on the project, the particular project. Adelaide is a state that is known for its architectural precast, and so the exception to that rule is that Adelaide will often send architectural precast, so high quality polished precast, for example, to Sydney, Melbourne and Canberra. Having said that, the majority of projects are locally supplied, and that's where, there's a sneaky environmental cost when it comes to using products that might be lightweight, for example, but they might be imported. And so there are a whole lot of environmental costs that go with that because of the transport miles. As I mentioned, on-site recycling is quite common. So precast will often use recycled water, recycled aggregate, often manufactured sand, and waste materials are recycled and reused. Moulds are reused, so most precast factories will manufacture precast in high quality steel beds, which gives a fantastic finish, but it also means that they're used over and over again. Once the structure is built, obviously precast concrete requires no chemical treatment to keep termites away. It's safe in fire and it won't emit fumes when it's exposed to heat or fire. It actually absorbs CO2, and it's been proven that it will actually absorb up to 40% of its CO2 emissions during manufacture. It will absorb up to 40% over the life of the structure. And of course, a big benefit is thermally efficient buildings have low operating costs, so they can be used in clever design to minimise the need for heating and cooling. Precast also offers a number of benefits to society. It's safer for workers. So rather than being on a cluttered construction site where there are deliveries, where there is waste, where it's all happening, you're removing a big section, a big chunk of the activity off-site into a safe, controlled environment where that's all they do every day. They've got the safety measures down pat. The biggest risk is using materials like precast or other heavy materials, but constructing them on site. So in situ concrete, steel and the like. Taking it off site, putting it in a safe factory environment is much better for workers. There's less disruption to neighbouring properties. So you've got exact elements being delivered. You haven't got the individual components that will make up the final product. It's high quality, of course. With advanced manufacturing techniques in the factories, you've often got additives being used in the precast concrete mixes. It's obviously fire, rodent, water and flood safe. It's long lasting and durable, which is one of its biggest benefits. From a sustainability perspective, a precast structure can last decades and longer, as we know, we've seen from the Roman concrete that's still standing today. It requires minimal maintenance, so there are some new innovations which I'll talk about later which mean that precast can actually be almost no maintenance over its life. Thermal efficiency, as I mentioned, so for occupants of buildings, whether they be residents in medium and high density living or whether it be offices, we've got lower operating costs because of the thermal mass of the structure. And finally, we've got adaptable structures. So we can achieve quite large open column-free spaces, which is particularly beneficial for example, car parks, where we need to minimise the number of columns. It also relates to using precast for your external skin of the building for its thermal efficiency, and then using a lighter weight structure for the interior walls, which then means that the building can be adapted in the future. Number of economic benefits as well from using precast concrete. It's supporting Australian manufacturing. And you know, there is a big trend to use other products. A lot of them come from overseas, a lot of them are imported, but at the end of the day, they're not supporting our industry here. And we talk about Australia and South Australia in particular losing its manufacturing capability. This is one industry that is actually growing that we need to encourage rather than discourage. There are obvious cost savings from fast construction, and fast construction means earlier occupancy. It's a good long-term investment. We've got durable structures that are robust, reusable, recyclable structures, and obviously there are procurement benefits from using precast. Stubborn, this little thing, isn't it? No. Okay. I'll now move on to have a look at a couple of examples. So this is one project in WA, Bishop C, and it was actually the first total precast Green Building Council 5-star Green Star building. It's a great example of a total precast project. Using external and internal columns, precast beams and hollow core planks. Another one, Melbourne Water. It comprised 2 9-level buildings. This particular one was driven by construction times that were needed, and these 2 buildings were actually built in only 8 months. Again, it was a total precast structure. It's a 6-star Green Star rating. It uses 20,000 square metres of hollow core planks, and they spanned anywhere from 8 to 16 metres depending on application. This one is particularly known for its 3D modelling that was used, where the building was built digitally before it actually started, and there were a number of challenges to be overcome with the different levels and ramps up the building to the car parks. And they managed to reduce the costs, meet budget, and achieve the construction time through some pretty clever design. This third one, Sydney SkyTrain, is an infrastructure for transport. Transport for New South Wales. Thank you very much. Project where the brief for this project, and it's a really good example of a truly sustainable project, it has addressed all three areas of environment, economy and society. They looked at the specific precast mix, wanting it to be very high quality and self-cleaning. So it uses a staining product, which I'll talk about in a minute, and a self-cleaning coating. Being precast, obviously, it was very high quality. There was a big push for the aesthetics to be just right and the colour to be right. There was a very lengthy sample process before colours were approved. It offers a number of benefits, but probably most notably the environmental and economic benefits are obviously fairly obvious. But what this one did is it actually made a point of re-engaging long-term unemployed back into the workforce. So TAFE, Western Sydney TAFE actually developed a job-ready course in precast for workers who would work on this project, and at the end of the project they are job ready. So that was a big bonus for this particular project, and I think that model is being considered by other infrastructure projects in New South Wales at the moment. Okay, so now I'll move on to talk about briefly some innovations that have been used in more recent years, and it seems there's still not a lot of knowledge about some of these things, even though some of them are not brand new. They might have been around for, say, 5 years or so. Staining is one of them. So there's a company by the name of Norcor who has brought staining technology into Australia. It's been used overseas for many, many years. It's a great alternative to paint, and it offers a low maintenance or virtually no maintenance facade. It does have a 25-year vertical surface guarantee, which means that it doesn't actually start to fade until 25 years has passed. So there's not even a necessity to restain at 25 years. It actually penetrates, as stains do, into the surface. The flexibility is fantastic in terms of what is available. So that particular project, there's Top Ryde Shopping Centre, which they were, there's a story to Top Ryde's shopping centre. It was meant to reflect an orchard. So the colours of that building were reflecting the colours of an orchard because of a local, Granny Smith, I think her name was, who actually lived in that area. So staining is available. It can be factory applied, or it can be site applied, or it can be factory applied and site touched up. It does come in every imaginable colour, including metallics. They can mimic Corten steel, for example, and it can be translucent or opaque. In fact, staining, this particular product has been used widely in the brick industry for a number of years here in Australia. Because typically what happens with house builds, so all the major brick companies use Norcor, with house builds, the pallets of bricks arrive on site and the brickie is meant to mix the pallets up, because bricks being a natural product like concrete, they don't. And so what they end up with is a bit of a patchwork effect like that building actually, with the different colour bricks from the different pallets. And so the brick companies, before they can hand over to the builder, will bring Norcor in to colour correct. So colour correcting is used not just in the brick industry, but it's actually also used in the precast industry, because concrete is a natural product and you can get some colour variation. But where colour consistency is important, the precaster can actually bring these guys in to achieve a consistent colour. It was actually used on the Adelaide Entertainment Centre, which was a black pigment project, and it was very patchy. Black's one of the hardest colours to get colour consistency with, and they came along and fixed it up using the stain. This is quite a new product to the industry. It's called graphic concrete. It's supplied in Australia by Ramsett Reed. It etches, what it does is it etches an image onto the surface of the concrete using retarders. This project you can see here is Perth Stadium. So they've used, it was an Aboriginal design to reflect the local Aboriginal people. It's all that's obviously all the detailing is all meant to be like that. And as you can see, it gives quite stunning results. So any photograph pretty well can be applied to the concrete surface. I was just going to say something that anyway. Another innovation is a product called Ecotio, and it's a photocatalytic coating. It uses nanotechnology, uses titanium dioxide. And so what it does is it does two things really. It self-cleans and it purifies the air. So it puts a very thin water layer on the external surface of the building, and then that surface attracts dust and pollutants, and then the rain washes it off. But it retains that thin water coating at all times on the surface of the building. So you can see there, it's been widely used in Japan in particular, but you can see in that photo, the building at the back has been treated, quite old structures, and the one hasn't, at the front hasn't, sorry. So you can see the difference that it makes, and that's now being applied to a lot of large infrastructure projects, for example, and buildings. Not such a new innovation. GRC has been around for quite some time, but it uses alkali-resistant glass fibres in the concrete mix. The beauty of using the glass fibres instead of conventional reinforcing is that it makes the facade panels lighter, and it's most often used for building facades. So this project is the Geelong Library and Heritage Centre. It's like a big soccer ball. It's won multiple national awards. The beauty of GRC, because it's sprayed on, you can achieve almost any shape, and you can also achieve very thin elements. I've been given the 2 minutes, so I'll speed on. Thermodeck is another really interesting product to look out for and to know about. It offers energy efficient heating and cooling. So what it does is it uses the thermal mass of the concrete to either heat up a building, so warm air can be delivered into that concrete flooring through the cores of the hollow core planks. They heat up the concrete slab, and then that heat is released into the building. Alternately, it can be used to extract warm air from an office environment, say. Sandwich panels are another fantastic innovation that the industry has been using now for some time. That's International Grammar School in Sydney. The beauty of sandwich panels is as you can see, it's the inner wall and the outer wall in one, with a layer of insulation in between, and they're held together by non-conductive ties. It's definitely a superior product for walling when it comes to a whole bunch of things: thermal, acoustic, fire, speed. It's incredibly durable. So the thicker concrete layer is actually on the inside of the structure, and the thin layer, so typically 100, 150 on the inside and about 70 on the outside. Double walling is another innovation. It's again, it's instant inside and outside wall. It's an off-form finish both sides, which is positive, which makes for easy finishing. The only disadvantage of this one is that it doesn't have the thermal mass benefit of the sandwich panels, but it's ideal for basements and car parks where you need a watertight solution. Modularised design. We're slowly seeing modularised design. I've got one more slide really. Modularised design creeping into construction. So more and more the industry and designers are looking at getting smarter in delivering complete modules, if you like, and then there are companies as well that are fitting those out pre-delivery to site. That one's Ravenhall Prison in Victoria, which has adopted a modularised approach. Then, of course, we have a lot of ongoing innovation that's happening, and it's mainly in the university space, and so in that regard, industry does welcome conversations with academia to talk about how we can work together going forward. Conductive concrete is one of them. Prefab wax moulds, which is Lang O'Rourke in Sydney, and it's come out of the UK, which is where they're using 3D wax moulds to cast concrete. And the concrete is cast into these wax moulds, and then the heat that's produced during the curing process actually melts the wax, and the wax can be reused. Self-repairing concrete, there are academics looking at the use of fungal spores, so from mushrooms and bacteria, to self-heal concrete. Bendable concrete, as you can see here, composite concrete, so using other materials as reinforcement, and obviously new products that are constantly being developed. So in conclusion, we've covered the sustainability benefits. I've shown you a couple of examples and talked to you about the innovations. I guess the opportunities from here, from industry's perspective, firstly would be to teach more precast concrete at universities, because consistently we are seeing graduates come out of university, whether it be engineering, architectural or construction management, who have very little knowledge in precast concrete. And with precast growing its market share quite considerably, that is a failing in the system. We do have resources that we can make available to universities in that regard, and I've got here to hand out for all of you, if you want a disc copy up the front here of our Precast Concrete Handbook. It's a disc version of this, which you can buy through our website, and then a small book just about the advantages of precast concrete. I'd also just call on procurement authorities, so government, to take the lead, and government to think about smarter building in terms of using more off-site product in construction industry. And that involves early collaboration with industry, because very often, and I've heard time and time again, that a project team will come to a precaster and will ask for help of how to reduce the cost in a project and speed up construction time. And time again it happens, but it takes that leap of faith to involve the precaster early and have that trust to be able to deliver an improved project. So on that note, thank you very much. Have you any questions?
Thank you very much for this